All right, so the answers to the vocab, we're going to go over that real quick, and then we're going to do section 2.1. So the answers to the vocab. Number 2, that is the zero product property. That's what we use to make factoring work. Why factoring can solve things so easily is because of the zero product property. Number 2 is vertex form. 4 is the discriminant. That is the radicand. Radicand means that that's what's underneath a square root value, okay? Or what's underneath the square root symbol. That's the radicand, and that is the discriminant. Then we have a real and an imaginary number together produces a complex. And then finally 6 is standard. Number 7 is complete in the square, but that is something that you did not do in this unit. We skipped that section. It's irrelevant for that. Okay, so now 8. 8 is asking about what is the transformation of this parent function. Now, this is in vertex form, so it's easy. It's easy to know. It's actually easy to see. You don't even have to graph it to know that you actually went to the left 2 and you went down 4. So the parent function at 0, 0 went to the, let's see, from your perspective, it's the other way, left, and then down 4, okay? 9, same thing. It's just that now we have a negative 2 in front, so that's 2 other qualifications to how it changed. This one is not only is it going to the right 1 and up 5, but it's also pointing downward because of the negative sign, and then the 2 means that there's a vertical stretch. Or we could even say that it squeezed in, or tightened, narrowed, whatever English words you can use so that I understand that you know that it's going like this. Okay. All right. Number 10. Number 10 is asking for many things. The vertex axis of symmetry, is it a max or a min, domain and range? But it's super simple as long as you have the graph. So let's graph this guy. Now I have the vertex at negative 3, 2. So if I know that it's negative 3, 2, it's got to look like this. Okay, negative 3, 2. Okay. Now if it's negative 3, positive 2, and it points downward, then I know that I have a maximum value. Okay. Now that's one thing, but the axis of symmetry is just this x-coordinate. X equals negative 3. So that's this guy. Now the domain, just look at the graph. You're going all the way from the left all the way to the right. Those 2 arrows will always suggest that it's the domain of all real numbers. And then the range, we start low and go high. The highest value that we'll ever get is positive 2. So we're going to put a bracket around that. We'll go up to 2, stop, and then come back down. All right. And so same thing with number 11. Let's get that graph. Okay, you go to positive 4, negative 3. So 4, 3. We have a vertex at 4, negative 3. Our axis of symmetry is x equals 4. Because this is pointing upward, it's got to be a minimum value. And the domain will be all real numbers because we're going all the way to the left, all the way to the right. That's what these arrows suggest. But the range means that our lowest value is negative 3, and from there on, we just go up as high as we need to. Okay, so that's 11. Now when we get to number 12, okay, number 12, it's all right, Obi. He's barking so much lately. He's paranoid. All right, so we have a vertex and a point that it passes through. Okay. Now, with the vertex, we can at least get to this point. We've got x is 2, the k, or I should say the h is 2, the k is 1. Okay, but we still need to know a. We need to know, is it going to widen or tighten to pass through this point, 0, 4. So what we do is we replace the x-coordinate with 0, and we replace the y-coordinate with 4. And then we're going to adjust this a so that it actually passes through that point. So we have got to do a little algebra. We're going to find out what 0 minus 2 is. That's negative 2. We're going to square that guy for a positive 4. 4 times a is just 4a. And now we're all the way back to the 7th grade where you guys solve 2-step equations. You're going to subtract 1. And then you're going to divide by 4. And if you have a fraction, so what? That's totally fine. You just replace that a now with 3/4 and bring everything that you had up at the top, that h and the k, bring that with you. So now you have this final equation. Now if I were to graph that in a graphing calculator, not only would I have a vertex of 2, 1, but I would also have, it would pass through 0, 4. Okay? Alright, same process. Now we have a different vertex. We have a different point. So we replace the y coordinate there, x coordinate there. Okay? We go ahead and find out what 3 minus 2 squared is. That's going to be 4. 4a plus 5 equals negative 1. Put the 5 over to the other side. Looks like I'll be dividing by 4 as well. So that gives me negative 3 over 2. No big deal. Negative 3 over 2 is just the fraction that goes inside here. You do not have to graph it. Alright, you are just getting the equation, and that will work. If I plug in a 3 here, I will square that after I subtract the 1, multiply by this, add 5, I'm going to get negative 1. I'm guaranteed that. Alright, 14. 14 is super simple because it's only saying that if I'm going to go down 4 and to the right 2, then it needs to look like that. Alright, I'm going the opposite direction. Now I'm given the description, give me the vertex form, whereas before you were given the vertex form. Okay, for 8 and 9 you were given the vertex form. Okay, and then tell me what's going on. Okay, so number 15, last one. Okay, now they want more points. Okay, let me see if that'll work there. Okay, so I'm going to kind of walk through this real quick. You have 5, 3 as the vertex, so 5, 3. It passes through this point, so we're basically doing the same thing that we did for 12 and 13, and we're figuring out what that A has to be. Okay, now the A. Okay, if you do the work here, you will notice that we plug in the 2 and the 21. That's the point that it has to pass through. We solve for A and get 2. So here's my equation. Now in numbers 12 and 13, that would have been the end of it. Okay, that's it. But now what I have to do is I actually have to plug in more values. I need to know what are other points that this parabola will pass through. Alright, so what I'm going to do is I'm going to choose numbers that are close to 5, because the vertex is actually 5, 3, and why not just choose 6 and 7, and then 3 and 4. I only have to have 3 points, so it's overkill if I do a 4th, but I'm really just going to go ahead and plug in numbers here. Alright, and I will only have to punch in most of it once, so how about we do, I'm going to get rid of this guy here. How about we do 6? So 6 minus, what was it, 5 squared, and then we're going to add 3. Okay? Okay, so 6, when I plug in a 6, I get 5. That's 1 point. The other one, I'm going to go up here, hit enter, copy that, and replace that 6 with a 7. You can do this on the other calculator as well. Mine's a little updated, but that's fine. Grab this, replace that 7 with a 4. I get 5. Okay, notice they're right there. So same output because 4 and 6 are on both sides of the vertex. So they should mirror themselves. And 3 should actually mirror this guy. So we're going to verify that. Plugging in a 3. I better get 11. And there's 11. Okay, so there's 4 points for you. Alright, that's it. That's the game. And move on to the next sections.